Okay, I wanted to get into section 2.2. Many people feel that this is perhaps the hardest section in the entire book. So we want to start off with looking at what we know and what we're going to. So let's first of all think about the shapes of these linear and quadratic equations. When you think about linear equations, they were equations to the first power, and they were just straight lines, either going at some angle going up or going down. There was no maxes or mins, and they had one root. So first power equations had one root. Second power equations, like quadratic equations, remember they were that parabolic shape going up and back down, or going from up and going back up, either a U shape or an N shape. And if you have an axis, they could have two roots. So second power equations could have two roots. Well, how many roots could a cubic equation have? Or how many roots could a fourth or fifth power? Another name for a fourth power is quartic equation. Fifth power is also called quintic, but people usually don't use those words. But fourth, you do hear quartic occasionally. And in fact, most calculators use that for fourth power. They use the word quartic. But how many roots could they have? Well, one of the fundamental theorems, in fact, it's called the fundamental theorem of algebra, is that the number of roots an equation can have is equal to the power. So a cubic equation could have up to 3 roots. Fourth power could have up to 4 roots, and a fifth could have up to 5 roots. That doesn't mean that it will have 5 roots. For example, a linear equation may have no roots. A linear, which is a first power equation, may have no roots. How's that? Well, if it went parallel to the x-axis, right above it, like let's say the x-axis is down here and it was a horizontal line, that equation would have no roots. Or a quadratic, if this is the x-axis here, if the quadratic came down and came back up and did not hit that x-axis, it'd have no roots. Or if it came down, hit the x-axis, just touched it and went back up, it would have one root. Or if it came down, hit the x-axis and went back up, it could have 2 roots, but that's the most it could have. Same way with a cubic. The most amount of roots it could have is 3. The most amount of roots of quartic, fourth power equation, could have is 4, and the most of fifth power could have is 5. Now, in terms of peaks and valleys, what does the power of the equation tell you? Well, if a linear equation had no peaks or valleys, like max mins, it just went up or just went down. There was no bend in it. A quadratic, well, quadratic equation would go down and come back up, or would go up and come back down. So it either had a max or it had a min. So a second power equation had one or the other. A cubic equation, let's take a look at that a second. I've typed in this cubic equation right here, just any old equation. Let me select it, and I'll hit graph. I don't know how well it's going to show up, but it shows up pretty nice. Now what you could do if you wanted to see this is I started off with a zoom standard. I looked at the coefficients and they were just nothing huge on them. So I did a choice 6 for zoom standard, which makes it a 10 by 10. And I got this much of the graph. Now I could have zoomed out if I wanted to, or if I look, most of the graph is happening that I'm interested in is somewhere around this area. I see a little min right there. So I could have gone to the viewing window, which actually I am going to go to. And to help you set the viewing window, use your table window some. For example, let me go to the table a second. And right now this is on ask. Let me set it back to, let me set the table back to automatic. I went second window, so I can set it automatic. Now let me go to the table. And actually it started at -13 for some reason. I should have changed that too. But looking at the y values, especially ones close to 0, I can see that the y doesn't go real high. 16 here, 28, 166. And so if you set your y's 100 high, you'll be fine to see part of the graph anyway. So I'm going to set the window, and I'm going to set my y max up to 100. And really, I don't need to go as far as I did up here. It looks like everything that's going on in that graph is happening pretty tight. So I'm going to make this -5 to 5. And now let's take a look at this graph. And so you can see the local max here, and here is a local min. Now, how many peaks or valleys does this cubic equation have? Well, it has one peak and one valley. Okay, one local max and one local min. So 2 total, one max, one min. Now this is not an absolute max. For example, if your domain went farther out here, this spot is definitely higher than this spot. Okay, so you need to check your endpoints when you do a restricted domain. And that's a later video, but it's an important one. So if you think about this, this is a third power equation. Actually, it only has one root, and that's fine. Like we said earlier, it could have up to 3 roots. This one only has one root, and it has a local max and a local min. Now if we would go to a fourth power, so it has a total of 2, one max, one min, and it's cubic, one less than the power. If we go to a fourth power, let's go to a fourth power equation, and what I did here, let me turn this one on, enter, and let me go back up and turn this equation off. Now on this one, what I did is I was just looking for any old fourth power or quartic equation, so I just typed in 3x raised to the fourth minus 5y1, so I'd have all this junk, 5 times that junk. The way I got the y1 here is I just did vars, y-vars, function, choice number 1. So it was, instead of me typing all this in. So really this equation is 3x to the fourth minus 5 times the quantity, everything up here. It gives you a messy fourth power equation. But we're just looking for some fourth power equation to show you with the max min. So let's take a look at this. I see it going down, and I don't see a lot else going on this. Here it is popping back up. So there's something going on in between here that I'm not seeing. So maybe I might need to go lower. So I'm going to go to my viewing window and set my y min maybe to -100. In fact, before I do that, let me look at the table a second of values close to around 0. And I can see that close to around 0 the values go -130 and so on. So I could see it well if I go at least down to -140. That helps set your viewing window. So let me set my y min to -140, and I always let my mins to be negative, my y mins and x mins to be negative, and my maxes to be positive. And now if I graph this, I can see the peaks and the valleys. Here's a minimum, here's a local max, here's another min. So we got local min, local max, and this min right here. 3 total, 2 mins and a max. 3, 1 less than the power. So that's a nice thing to realize, is that the number of peaks and valleys is no more than 1 less than the power. For example, if we had a fifth power equation, the number of peaks and valleys could be no greater than 4. You could have maybe 2 mins and 2 maxes. Doesn't mean that it's going to have that many, but it's no greater than that many. Now we could use certain things to get like this min right here. We could do that G second trace to calculate, get to the left, get to the right, and get that min, get this max doing the same thing, and get this min. This would be a local min, because if you think about it, over here, anywhere over in this area, it's lower than what it is here. Local min. This would be a local max, because anything on this side is higher than that, and this is higher than that, so this is a local max. This, though, is an absolute min, because the graph does not go any lower than this spot right here. Now if we have a restricted domain and somebody says, what's the minimum from, let's say, here to here? Well, it would be this spot right here, would be the minimum from here to here. If they said, what is the maximum from here to here, let's say, well, your calculator might find you this maximum. But if you check the endpoints of the domain, you would find that this spot is higher. Okay, so you need to check the endpoints of the domain, and we get into that pretty heavy. But at least a general idea to get all the graphs showing up is to use the table menu to help you see how high and low it is, and then using that window button to set your y min and y maxes high enough to see the features of the graph. And of course you can use your max min program to find these max mins, and your max min program helps you check the endpoints of the domain, or the table can do that also. And you also should know then how many roots this could have. Since it's a fourth power, it could have up to 4. This one only has 2. Will not have any more than that, since I know that it only has 1 max and 2 mins. I've taken care of all the maxes and mins here, so there's no way this thing can curve around and come back down. And hopefully that helps you see the graphs that we're getting into here.